Appreciate you all for being here. I just want to be sure that you can hear me okay. If you could give me a thumbs up or something, that would be great. Awesome. Thank you. So again, thanks to everyone for showing up and welcome to week 2 on our occupational exposure assessment coaching series. Today we're going to do a brief introduction into exposure decision analysis. I'll talk about what we're going to do. So we'll cover objectives for today, which, as before, the first bit of our session today, about 30 minutes, will be focused on on a transfer of information from me to you. After that, we're going to do some practice, some hands-on, and I'll answer any questions you may have. So we'll do a quick review of week 1. We'll talk a little bit about what is under the hood of the tools that we're going to discuss in a couple of weeks. So we're going to do our third week in 2 weeks, our third session, where we actually go ahead and use the tools. But this week we're going to talk about a method for you to determine the exposure rating and control category without any fancy tools or even a calculator. I guess I say we're not necessarily determining it, we're estimating where it would be. Most of the time this rule of thumb works. Not always, not always. I've seen where it's off. It's sort of a ballpark estimate. It's the sort of back of the napkin estimate that you might do in the field if you were given a few numbers and were asked to make a judgment about it without having time, let's say, to run numbers through a tool. Uh, Otherwise, obviously, you'd want to use the tools that are available. They're awesome and they're free. So there's outside of that sort of scenario, there's not really a good reason to not use the tools. And like I mentioned, we'll do some practice. So we'll spend some time practicing with some small data sets, and I'll answer any questions you have after that. We'll do a review as well. At the end of this session, you should be able to explain 3 assumptions necessary for exposure decision analysis, summarize 2 steps for analysis, and then determine the ERCC using the rule of thumb and a small data set. So a quick review of week 1. Something that's really important, and we dove into a little bit more detail last time, but I want to just highlight the important pieces here, most important parts. One is the difference between population and sample. So I showed a graph where we had the exposure that one worker would experience throughout the year. Typically 250 days. Most workers will work around 250 days a year. Hopefully a little bit less if you get more than 2 weeks of vacation. And if there's sick time, etc., then it might be a little bit less, but 250 is a nice number. So we might sample 5 out of those 250 exposures, we might sample 5. And I would say we'd be lucky if we had 5 samples on one worker in a year. That, in my experience, doesn't happen very often, if at all. So if we had 5 samples, that would represent 2% of that worker's exposures. The 5 samples is what we would refer to as a sample in statistics. In statistics, we would refer to that as a sample. The 250 exposures, we would refer to as the population. So we can estimate different things where we can calculate the geometric mean, the median, the 95th percentile. We can calculate a confidence interval for our sample, but we cannot do it with a lot of certainty, I guess. Well, we can't know where those things are for the population because we didn't collect all of those samples. There are another 245 samples we did not collect. And so we don't know where those were, how high or low those exposures were. That's why we use the tools to try and estimate where they might have been and where our 95th percentile might be for the population. So that is our focus, is determining where that 95th percentile is for my population. And so on a distribution chart like this one, 95% of the data would fall below this line, somewhere around here. The reason we're so interested in the 95th percentile is that we want to be able to say with 95% confidence that 95% of our workers' exposures are below our exposure limit. We want to be able to say that. And so to be able to say that, we need to know where that 95th percentile is for the population. And when I say population, it's not just the one worker. We used one worker as an example. It's every worker in that SEG. So it may be one, it may be 10 or 20 or more. The point is, we need to know where that 95th percentile falls, and that will let us be able to determine whether we can say that with 95% confidence that 95% of our exposures are below our exposure limit. So that's the goal of the analysis. We're gonna talk about ways to do that, obviously, like I mentioned, without the without the tools. I wanted to emphasize once again the free course from AIHA. I highly recommend that if you're interested in this field, that you go ahead and invest the time to take this course. It is free. It is a free course. You will need to create an account with AIHA, but you don't have to pay for membership. You do not need to be a member of AIHA to take the course. You just need an email address, create an account, and then you can take the course. I highly recommend it. They also have this registry exam, and as of so I Larry Sloan, the CEO of AIHA, presented to our department today at Tulane, the Environmental Health Sciences Department, and shared it. And this number is in the 700s. It's something like 732. I think that was as of today. He had checked the registry, but there is an exam that you can take for free. Again, for free with AIHA. You just need an email and you need to create an account, and then you can take the exam. It has two sections. I recommend that you complete the course first. That will prepare you to pass the exam. Once you take the exam, then you will be listed in their registry. So it's another credential you can add to your name. That's great. But the most important part, obviously, is being able to use the tools effectively to protect workers. So just a little bit about what's under the hood. I don't want to dive into Bayesian statistics here. That's not the point of this. The point is just to share a little bit so that you know a little bit about the Bayesian statistics. I am not a Bayesian statistician. That is not my area of expertise. I understand a little bit about what is happening, but we don't necessarily have to understand how the engine in a Ferrari works. We can open up the hood, we can look at the engine. Wow, that looks really nice. I might be able to recognize some of the parts, and hoses and things, but I am not a mechanic. I am not an engineer, and or an industrial designer. I don't know exactly how it works, and that's okay. I just need to know how to move the steering wheel and shift gears, right? The brake pedal, the gas pedal, some of the basics. And that's the way it is with these tools. These tools are a Ferrari. You don't need to know how the Ferrari works. You just need to know how to drive it, right? And how to interpret the results. So that's going to be our focus, but I wanted to just lift up the hood a little bit, give you a peek at the engine here. So Bayesian decision analysis, is a framework for making decisions under uncertainty. And the idea here is it's not listed as a bullet point, but for small data sets in industrial hygiene, we're typically dealing with small data sets. We don't have a lot of data to work with. And so we have a lot of uncertainty. The smaller our data set, the more uncertainty we have. As we add data points, that will go down. Still, the tool is an excellent choice for us to use in under this sort of condition, lots of uncertainty. It incorporates prior knowledge. So what that means is I'm going to look at this little graph here at the bottom, and it kind of explains here. So this might be what we thought. This is where we thought we were with our exposure profile for our similar exposure group. So let's say we have a group of welders, and we think that they're about here when it comes to that 95% UTL or the 95th percentile for our population. We might think that they're right there. We run the data through the tools, and the data tell us, well, actually, it looks like it's right here. And what happens is we adjust where we are based on the two here. Now, what I say here, when it says before seeing the data, we're going to perform a qualitative assessment before we do any sampling. We may have an idea, but we're not going to put very much weight into this initial judgment with no data. After we do have data, so the caption says without seeing data. After we have data, then let me I'll just stick with blue here. This this peak is where we were before we collected new samples. So let's say we've collected 5 samples and we're going to collect another 5 samples. This is where we're at with 5 samples, but our new 5 samples say, well, actually, we're probably closer. The new set of data is over here, and so it's going to adjust where its analysis and where its estimation is for our decision statistic, which happens to be the 95% UTL or 95th percentile. So it keeps adjusting its estimation based on new data. So we can start with an N of 1. That's one cool thing about this about these tools is we can start with an N of 1, and as we add more samples, it will adjust and it will update its estimation, and get us closer and closer to hopefully what the reality is. So explain that idea, and its focus is on decision making. So it's going to give us an output. Yes, it'll give us decimal values for the outputs, but the main point is, so what? Like as some of my mentors or advisors would ask is, so what? You did this analysis, you have this report. So what? Well, this is going to help us determine where we're at, most likely, and what we ought to do about it. And I think I mentioned this last time. It's one thing I love about these tools is it's very focused on practicality. The so what? So a few things that we need to be able to say before we do our analysis is that we have a well-defined similar exposure group. So sometimes that's easy. Say I have a group of welders, it's a crew of welders. Well, and they do they share their tasks. They do everything in the same area, similar processes. Well, okay, that's pretty straightforward. That's my SEG. But sometimes there are differences that may require me to break that apart or combine it with other groups. So let's say I have 2 welders on my crew they do strictly stick welding, and I have another welder that does TIG welding. I have 2 others that do MIG welding, and they never change. Well, then I might have 3 SEGs there. I might still just have one, but I might have 3 small groups within that crew. So we'll have to have put some thought into that and defined what our group is before we do the analysis. We also need a well-defined decision statistic. We have that. So we have that. That's the 95% UTL. So that one's taken care of. We have an exposure limit that is appropriate for our group. That one typically isn't too hard to find. Sometimes you're assessing something that where there is no exposure limit. That's hard. That's hard. And these tools may not work for you then. You're going to need to use a different approach. But we're assuming we have an exposure limit we can use as a threshold as a reference. We need a sampling question. We need a sampling strategy. We need good monitoring methods, a good analytical method. So we want to use methods that, as it says, that are validated, that have been shown, demonstrated to be appropriate and relevant for our exposure. Assuming we can check all of those boxes, then we can move to the next step. Now, today, we're just going to use the rule of thumb. We're not going to dive into the tools just yet, but it'll give us an idea. We'll sort of do a warm up. Next week, we'll do, maybe I should have done an overview of our weeks, but so week one, we we talked about some stats. This week we're going to do the rule of thumb next in 2 weeks. So in our next session, we will use what's called Expo Stats. It's a web-based tool. The thing I like about it is you don't have to install anything on your computer. If you're at a work computer, you should. I don't think your IT department will have the website blocked, the domain blocked. So, there's nothing weird about the site. So you ought to be able to use the tool there. Then we'll look at interpreting our results, and the last day we'll look at controls. So let's talk about the rule of thumb. Now, these are all the steps to analysis. We're not going to do all of these today. We're actually just going to do a couple. Next week, we will go through the full process, but I'm kind of breaking this down into pieces. We're going to focus on the core aspect of it where we are going to estimate our 95% UTL and compare it to our exposure limit, and then decide where our rating and control category are. So to use the rule of thumb, you do not need to know this equation. Not that it's super complicated, but this is just kind of for a reference, FYI. If you were going to estimate the 95th percentile, I say estimate, we can calculate this with our sample, but here we're going to modify this and simplify it. Like I said, this is back of the napkin. I'm out in the field. I can't use my phone to do this on Expo Stats. I'm not able to do anything like that, and so I am um, I am again, it's just a quick and dirty estimate for our to determine what our exposure rating might be. So the geometric mean, we looked at this a little bit last time, but the geometric mean is actually, it tends to be close to the median. It's rarely identical, but it's close. It's pretty close, and it's closer than the arithmetic mean. It's closer than the mode. It's closer than other options we have for measuring the middle of our data. And so instead of the geometric mean, we're going to use the median. We're going to use the median, and then we're going to use some multipliers. So this is the equation we're going to use. We're taking two numbers and multiplying them together. That's the amount of math we're doing. So most of the time, I think you might be able to do this in your head or at least on a piece of paper. You wouldn't even need a calculator, although I'm sure you'd have access to one. So let's take a look at the multipliers. What do I mean by multipliers? Well, If you look back to the original equation, you see it has the geometric standard deviation raised to this value. We're not going to mess with that. We're not going to mess with that. Someone else has done the math for us, and they and has found that, well, they plugged in the numbers and found that, well, if you take 1.5 raised to that value, you get about 2. And if you take 2.25 raised to that value, you get about 4, etc. So 3 gives you about 6. Someone else did the math for us. We don't have to. It's a way for us to guesstimate the variability in our data set. Now, this is from a IHA's course. Most of this table is this column right here is Rustin Rustin's estimation on this. It's Rustin's estimation on where on the variability. It's one way that I use to, again, just kind of ballpark how much variability is present in my data set. So what do I mean by my min max here? Well, we'll take a look, but basically you're going to look at the minimum value in your data set and compare it to the maximum value in your data set. And if they're different by less than a factor of 2, then my experience is most of the time you're at low variability and you're going to use a multiplier of 2. If that difference is around 5 times, so let's say, with this first one, it might be, I might have a data set that looks like this: 2, 3, and well, we could say 2, 3, 4. So 2 to 4, that's a difference of 2 times. That's not a lot of variability. It's probably in this category. But if I have some numbers and my max value is 10, so 2 is my min, 10 is my max, then it's around a 5x difference. It's probably around here, medium variability. And let's say I have 2, some numbers, and my maximum value is 30. 2 to 30. Well, that's more than 10 times greater. 30 is more than 10 times greater than 2. And so I'm going to use this one then. Sorry for all the scribbles here. So one other I'm going to erase my scribbles. One other very important thing. We're going to take a look at an example, walk through a couple more examples, and then I'm going to have you practice. So if that maximum value, so we're going to look at that max value in our data set, is in an exposure rating or control category all by itself, then we cannot pick a category that is lower than whatever that one is. So we'll take a look at all of these in just a moment and to see what they are. But that's an important rule. So we need to make sure we check what the maximum value is, where it is, excuse me, in which category it falls, for us to be able to make sure that we're not underestimating our rating. Now, this is the rule, but what does all of that mean? So first, let's look at our exposure ratings down here. And you know what? I'm going to it's just kind of small. So I am going to swap here and share a larger version of that table. Okay, a bigger version. Bigger is better in this case, I think. So what I'd like you to pay attention to is the numbers over here on the left side. This is exposure rating category, and those correspond to control categories. This is all in terms of percent of our OEL. So let's say our OEL is 100 parts per million. Oh, I forget. I can't touch the top of the screen in PowerPoint or it kicks me out of the slideshow. So 100 parts per million. So if my estimated 95% UTL is 1 part per million or less, then I'm going to fall in this category. So again, that's if my OEL is there and my estimated, when I say 95% UTL, I've estimated the 95th percentile for my exposure group. If I'm at 1 part per million, then I'm in this category, which is a nice one to be in. If I'm somewhere between 1 and 10 parts per million, I'm going to be in this one, and so on. So you could replace the percent here with parts per million in this example because my OEL equals 100 parts per million. It makes the math easy. And we're going to only use 100 parts per million for our math today, but we can talk about what it would look like if it wasn't 100 parts per million. You might want a calculator at that point, but still pretty simple math. So you can see we have we have 5 categories, 0 through 4, and we are we are comparing where we are at in relation again to our OEL. It's all in relation to our exposure limit. Okay. Everything is in relation to our exposure limit. So let me go back to where we were, and hopefully that helps with some understanding. So let's walk through an example. I think that'll help a lot. Walk through a second one, and then I'm going to let you practice a little bit here. So in our first example, we have an OEL of 100 parts per million, and these are our samples. We have 1 part per million, 2, 3, 5, and 8. Okay. Couple of things for us to check before we move forward. One is we want to see where that maximum value is compared to our OEL. So at the last bullet point on the previous slide had said if this value falls in a specific category, then our final selection cannot be a lower number. So let's compare this. So eight is what percent of 100 in terms of a percent? Eight is what? Eight is what percent of 100? Good, good. It was kind of quiet, but I think I heard that. Yeah, exactly. It's going to be 8%. 8%. So I look at my categories here and I see, okay, this one has 1 to 10%. So that sample, if we're just looking at it by itself, it would fall in that category. So after we do our estimation, we know that our what we select it cannot be 0. We cannot pick 0 for our category because one of our samples already, we only took 5 samples and it already falls in this category. So 0 is not an option. 1 could be an option or maybe something else, but 0 is not an option. So we looked at our max, compared it, that was 8%. So that tells us the floor here, the and I think maybe we should rearrange the table so that 4 is on top, 0 is on bottom. I talked about going up and down, and that might be a little confusing here. But anyway, so So we cannot go on this table, we cannot go any higher, or in terms of categories, we can't go lower. We're gonna have to pick something lower than my red line there. The next thing we're gonna do is we're going to look at the min and max. So I had mentioned the min max, the difference between the two. 1 to 8 is it doesn't fit neatly into my boxes here. So that's an 8 times difference. 1 times 8 is 8. So it's probably not this one. I would say it's probably going to be in here between one of these two. It might be this one. It might be that one. For now, I'm going to say that I'm going to say, well, maybe it's here. You wouldn't have to just pick one of these if you're kind of splitting the difference like we are right now. You could say, well, maybe it's around 5. Maybe it's around 5, and I'm going to multiply by 5 instead of 4 or 6. Again, this is the back of the napkin ballpark estimate. But just for fun, let's do both 4 and 6 and see where that puts us. So I'm not going to worry about 2. Oh, sorry. I'm jumping the gun here. So the steps we've gone through, we compared the max with the OEL. Number 2, we looked at the min-max difference. So it was 8 times different. And number 3, now we're going to find the median. After that, then we can do our math. So I see here that the median is number 3. You got a quick review of that median, and you know, I think we talked about median, but not exactly what it is. Median is a word that literally means the middle value, the middle. So median means middle, the middle value. So if we rank order our values from lowest to highest or highest to lowest, doesn't matter as long as they're in order. We pick the number that's in the middle. So here that happens to be number 3. So my median is 3. And now I'm going to multiply 3 by those two multipliers. We talked about 4 and 6 based on that estimation from our min to max, the amount of variability. So let's just do them both and see what we get. So if we do 3 times 4, that's 12. 3 times 6 gives us 18. 12 and 18. And if we might still be indecisive about which of the two we should use. Do we use 4 or do we use 6? Or maybe split the difference and multiply by 5. I might still be indecisive, but after I've done this, I see it doesn't really matter because both of these are between 10 and 50% of my OEL. Both of them are in that 10 to 50% range. And if I look at my table, that is this category right here. So whether it has medium variability or high variability, at least in this example, it doesn't matter. They both fall in that category. So that's my category. So I checked my max to make sure that I don't go, I don't pick a category that's higher on the table than it. I looked at my variability to see my multipliers. I found the median, which was 3, and then I multiplied the median by my multipliers to see where I'm at. And in this case, so that last step, let me say that I'm comparing these with my OEL of 100 parts per million, and that's 12% and 18%. of 100. So that's how I then arrive at that. So I'm going to walk through one more example with you, and then I'm going to let you try on one. We'll talk through it, and then I'm going to let you try a few different examples. So let's go to another one. Example two, I'll walk through again with really, there's four main steps we're using with the rule of thumb. Uh, so first, sticking with the order that I used from last slide, the first three, it doesn't really matter which order you use, uh, but it's just helpful. I put that max one first because sometimes I forget to do it. Sometimes I forget to do it, so I'm doing it first. So I'm going to compare my max with my OEL. That's 20%, 20% of my OEL. So I need to see where that is on my control categories or my risk categories. I see that that's in category two, so I'm not allowed to pick either of these. Not allowed to pick them. It's going to be one of these three. I'm going to check the variability or the difference between my min and my max. 20 divided by 3 is around, I guess I should say, not equals to, but it's around 7, not quite 7. That is, if you remember our options, there's 2, 4, 6, and I had said a change of about 2x, 5x, and 10x. 7 is fairly close to this medium range, so I'm gonna stick with that for now and just see what that does. But again, like last time, we could also do 6 and see if it makes a difference. Excuse me. So I'm not gonna worry about 2. Before I can do that, though, I need to find my median. So I look, and this time I don't have 5 numbers in my data set. I only have 4. What to do about that? Well, to find the median, we just find the middle of these two numbers. We have 5 and 12. We've got to split the difference, and that's going to be 8.5. So we could take the average, or you could kind of count that in your head if you wanted. Uh, it's going to be 3.5 from this side and 3.5 from that side to meet in the middle. We get 8.5. So our median is 8.5. Now we looked at the max. We looked at the amount of variability between our min and our max. We found our median. Now we can do our math. So I'm going to take my median, 8.5, multiplied by the multipliers, so times 4 and times 6. So I talk about doing this in my head. Okay, so from that we're going to get 2, and from that we're going to get 32. So that's going to be 34. That one is 34. And this one down here is going to give us 51, if I'm doing that right. That's in my head. Sometimes that's dangerous for me to do math in my head, especially when it's been a long day. So, if I'm wrong, please correct me there. So I check my two numbers with my categories. And here it does make a slight difference. So remember, 100 parts per million is my OEL. And so that would be 34% and 51%. So it's a choice between category 2 and category 3. Now I'm leaning more towards category 2 just because this one is barely into category 3. And 7 it's pretty close to 5. My little rule of thumb of 5 times It's a little bit closer to that than something a little more extreme. So in this case, I would select category two, and I would go with that one for my exposure rating and control category. So I'd like you to take the opportunity to do this yourself as well. So with example three, go ahead and work through that. I'll wait a couple minutes. I'm gonna write on here the steps that I took just as a quick reminder. And and once you have an idea, what I'd like you to do is in the chat put the category that you think we're in from 0 to 4. So it's going to be 0, 1, 2, 3, or 4. So go ahead and just put that in the chat once you have your answer. This is the time to practice. This is the time to make a mistake because we're learning, right? That's how we learn, and it's an opportunity for us to get better. So first, check your max against the OEL. Then look at that min max difference. Find your median, and then take your median multiplied by your multiplier. So I already got one answer. That's awesome, Amanda. For anyone else you don't have to be that fast. That's pretty fast. If you're a little bit slower, that's okay. Got another one. That's awesome. Good answers coming in. Gonna wait just another minute, maybe. Awesome. So let's walk through this one real briefly, and then we'll get to the next slide with a few more examples. And I'm going to, let me see here. I guess I can't. Uh, I'm going to erase all the notes. Sorry. Uh, so remember our last one we picked was 2. Let's take a look at this one. So step 1, I'm going to compare. Let's stick to the same coloring. I'm going to look at my max and compare that to my exposure limit. I see that's 63%. So we're already way down here because that's 50 to 100% right there. We're already there. So it's going to be category 3 or 4. It cannot be one of these. So we already eliminated 3 options. We're down to just 2. I'm going to take a look at the min to max difference. I see that it's greater than 10. So 63 divided by 5. I don't know what that is exactly, but I know it's greater than 10. Because if it was 50, it would be 10. So I'm going to use the 6x multiplier. I'm not going to worry about those. And then I need to find my median. So I look, I see now I have 6 values. So I have an even number again, which means I've got to find the middle of these two. If I split the difference between 13 and 17, I get 15. So my median there is 15. Now I'm going to do the math. So 15 times 6. And okay, that should be 90 if I'm doing the math correctly. Well, I have another slide to show the answers to make sure I do this right, but it should be 90, and 90 falls in category 3 as well. So our max value falls in category 3. Our multiplier with our median lands in category 3. So it looks like we are in category 3 here. So let's just take a look at the answers just to be sure that we're on the right track here. So it was 8.5 there. We compared that there and found that we were here with the 20. The 20 is in here. So we said it couldn't be those two. I did the math for all of the multipliers just to see, out of curiosity what things would be. So we did get 34 and 51. We ended up with 2 there. Here we eliminated the 2 and 4 as options, and we stuck with 6 times 90, and we also ended up with category 3. So this is just to show you those same numbers plugged into Expo Stats. We're going to take a look at this in more detail next time. So we'll be doing this in 2 weeks in our next session. But the same numbers in Expo Stats showed that, yep, category 2 was our most likely category. And in example 2, it was a little bit closer, but category 3 was still the most likely category. And so our rule of thumb in these 2 cases ended up being accurate. Like I said, I have seen where it's not the same. That's okay. It's again just a back of the napkin, just a quick estimate, uh, and not meant to replace using the tool. So let's take a look at these practice problems. So just each of these is a different example, different data set. Go ahead and use the OEL of 100 parts per million. Use the same rule of thumb, and work on these. So I'd really encourage you to if there's something you don't understand, ask a question. Right now is our time to work through any of those sorts of things. I feel like I'm talking way too much. I want it to be more coaching. So anyway, if there's a piece here you don't understand, I'd like to know so that I can address that. But go ahead and make an effort here. If you have a question, let me know. So again, you'll in the chat go ahead and list which category we're in from 0 to 4 for each of these. And you know what? I ought to have more information on this slide. I forget you may not have access to some of this, so let me write some of it here for you. Something I need to change here just to be uh, better design here. But we have less than 1%, 1 to 10, 10 to 50, and for our multipliers, I also forgot about those. But when the min max difference is less than 2, then I would do 2. This is your multiplier. If it's around 5, I would do 4. And if it's greater than 10, I would do 6. And I'd say if you want, just do one at a time, or just one of them for now, and we can talk through it. Good. We got a few answers. Awesome. Y'all are fast. Excellent. Very good. So far, everyone's perfect. I think that's less a reflection of me and more a reflection of you. So for those who I do want to walk through it briefly for those who may want some help here. Uh, I guess I'll leave my notes there. We'll do this with less notes, less scribbling. So if we check our max here on the first one, it's 10. That puts us down here. So or or we might call that category number two if we want to be a little bit more conservative. But we can't pick zero for sure. We look at the difference between these two numbers and we see that that is 10x. So we're probably going to pick 6 for our multiplier. We find our median, which is 3. We multiply that by 6. 3 times 6 equals 18. So that puts us squarely in category 2. And like I said, everyone got that perfect. And the goal isn't perfection. I mean, that's nice, but if you don't understand, if you have questions, then please let me know. Um, I want to help. So we'll look at our next one. We look at our max. That's 32. That's going to put us in category 2 at the very minimum. If not, then we'll be higher at 3 or 4. I look at the difference between these two. I see that's greater than 10x. So I'm probably going to multiply by 6. So I find my median right in the middle. 4 times 6 gives me 24. So this was in category 2. This is in category 2. So I'm going to stick with category 2. And for the last one, check this against my table. That's going to land me in category 3. Now let's look at our variability. So I do that. That again, once again, that's more than 10 times different. So I'm going to do 9 times 6. That's my median. 9 times 6. It's going to give me 54. If I'm doing the math right, 54 also lands us in category 3 for that. And so this one would be category 3. I do want to emphasize once more, real quick, that this little piece is just me. So it's not perfect. I promise that, but it helps me in figuring out where I should be with my multipliers. And most of the time, it's served me well. Like I said, it's not perfect though. So what we just saw, we got 18, 24, and 54, and that gives us 2, 2, and 3. Okay, so we went over briefly our week 1, or I should say maybe session 1. We talked a little bit about the Bayesian. We looked over the rule of thumb and then we did some practice. I appreciate all those who participated. And now it's open up for questions. So um I talked way more than I wanted to. uh so I'd love to chat if anyone has any questions. I appreciate that, Leanne. Last time we had several great questions. And I appreciate those. Any questions? So we're going to do this again in 2 weeks. That means it will be March 11th. March 11th. It will be at the same time, so at 7 p.m. Eastern, if you're in the US, 7 p.m. Eastern time, we will do this again. We'll start to use Expo stats and make sure we we understand that. And I'll be honest, I learn every time I try to use the tools when I am reporting my sampling results, and I learn more about maybe better ways of communicating. It's more about better ways of communicating the results and interpreting the results. And so next time we'll talk about using the tool, after that, interpreting, and then finally your control recommendations. And I do want to say, I do feel very strongly about this initiative, this effort. I would really like more industrial hygienists and EHS professionals to be familiar with these tools and use the tools. Um, uh, I want to help people learn how to do it. I want you to learn how to do it yourself. If anyone wants help doing it, then I can help you, and that's what's going to be on the next slide. But I like coaching, and I'd like everyone to learn how to do it, and so that's my focus. Um, and so yeah, I appreciate everybody for your participation. Oh, yeah, that's awesome, Amanda. And use tomorrow. Yeah, I'm a huge fan. I'm a huge fan of the tools. Um, and yeah, I really like them. I'm a nerd. Maybe we're all nerds in our own way, but I really geek out over this sort of stuff. So, yeah, but let me know if you have questions. And like I said, in 2 weeks from tonight, we'll do it again. Oh, nice, Mandy. Good. I hope it's helpful. That's awesome. Yeah, you're welcome. You're welcome.